Okay, so next we have this. So to evaluate this or to prove this identity, it's better to use the left hand side. So for me, I can find the common denominator for this first. Let's leave this guy alone for now. So this one will be 1 minus sine x, 1 plus sine x, and then minus 2. So 1 minus sine x into the common denominator will just be the other one here. The same applies to this. This one into this will just give us this one here. So 1 minus sine x, like this. And then we can rearrange this. So we have a 1 plus 1, and then sine x minus sine x, then everything over 1 minus sine x, 1 plus sine x, then minus 2. 1 plus 1 here is 2. This minus this is 0. And then we have this, which we can expand using the difference of two squares. So the difference of two squares tells us that when you have a minus b, then a plus b, the product will be a squared minus b squared. Or when you have this, you can factorize it like this. So let's just apply it. If you want, you can still expand it the way you normally expand binomials. So this times this is a 1, and then this, actually this one is not. Anyway, we have different nomials here, so it's better to either use the difference of two squares or you just expand it the way you would normally expand numbers. Okay, of course we have a minus 2 there. So we are trying to find 2 tan squared x, which is like 2 sine squared x over cos squared x. So to do that, make sure that you have a cos squared in the denominator. So let's change this to cos squared. Of course, from this identity, we know that cos squared x is equal to 1 minus sine squared x, which is exactly what we have on the denominator there. So you can say 2 over, instead of writing this, we can have cos squared x minus 2. So now let's simplify this and see what the numerator will be. So the common denominator here will be cos squared x. This one there is 1 times that, 2. 1 into this is cos squared x multiplied by that. This will be 2 cos squared x. So now when you look at this, we want a 2 on the numerator and a sign. Here we have some 2 and cosine. We want to change this to cosine, to sine. So we can still use this identity, but to use it, it's much easier to see when you factor a 2 out. Factor a 2 out, you have this one. Okay, this one is, if we were to make cos x the subject of the formula there, this would be sine x. Let's make sine squared x. It's okay to make this one though, but I prefer making sine the subject because I can clearly see this part there. So where we have 1 minus cos x, which is the same as sine squared x, we can write sine squared x. So here we have 2 sine squared x, everything over cos squared x. And by definition, like from the definition, it follows that this part here is tan squared x, which proves the identity.